Hello everyone and welcome to another video of VV clones. In the last video of PepCoding Level 1 that we had made, we had revised this sliding window maximum question, right? So in this video, let's continue to solve the stacks module that we have, and we'll try to solve the next questions that we have in the stacks module. Okay. And just a refresher, before that we have revised all the questions like next greater element to the right, next greater element to the left, and stock span. So this question that we had solved, sliding window maximum question, here we had tried to find the right boundary first, and we then whatever the right boundary was, we had two variables I and j. So j used to jump from one greater element to the next greater element, if you see here, and we used to compare if the next greater element is within the boundary or not. Like that's what we are doing here. And I have done some more optimizations here, and this is the final code that we have here. So let's continue solving more questions of pep coding. So we are in this arrays and stack module. Let me go there. Not stack and queues module. So the next question is infix evaluation question. Okay. So we are given like there are before solving this question, there are three types of expressions that we have: infix, prefix, and postfix. So in this question, we will be particularly focusing on infix. So what is infix expression? So infix expressions are the expressions which are understandable by humans. Okay, so if we have, let's say, kind of this expression, a plus b, so this is understandable to humans. Or we can have uh, an expression like 2 plus 3 minus 1. These all are infix expressions which are understandable by humans, and we have to evaluate the infix expression and print its value that we have. And we are given some constraint that the expression is balanced. Like whenever we have a closing bracket, there is uh, whenever we have an opening bracket, there is a closing bracket. The only operators are plus, minus, multiplication, division, and um, the opening and closing brackets are used to impact precedence. Like these will get precedence. Like if you know the BODMAS rule, like mm, all these constraints are telling us the BODMAS rules. And one more condition that we have is all operands are single digit numbers. So if we have this kind of expression, we'll have to evaluate this. So how do we approach this question? So what we can do is that we can have this expression here, and we can create two stacks. So one stack will store all the digits that we have, and we'll have another stacks called as the operator stack, which will have all the operators. Okay. So what we will do is that whenever we'll iterate through this string, and whenever we encounter a digit, we put it into the digit stack. Whenever we encounter a operator, we put it into the operator stack. So first we have encountered 2. Then so let's say this is the mm, operands. I'll call it operands, right? Operand stack. Okay, so we have put 2 in this operand stack, and similarly we will have operator stack as well. So we have plus inserted into the operator stack. Then we have 6 inserted into the operand stack. We have multiplication inserted into the operator stack. And then we'll have hmm, mm, we'll have 4, right? 4 into the operand stack. Then we'll have division. So we have some set of conditions here. So we have been given the constraint that plus and minus are given lesser priority than multiplication and division, right? So what we will do is that whenever we encounter a character which is having higher priority, what we will do, we will have a stack dot peak. So if we do stack dot peak now, we got this, we are iterating over this character now. Okay. So whenever we get a stack dot peak of the operator array, we will check if the precedence of this operator that we have here is it greater than or equal to the operator that we are iterating. If it is greater than or equal to, then what we'll do is we will pop this and then we will evaluate these two operands. So we'll get that operand from here and then we will do 6 times 4, which is 24, and we will push this 24 into the stack, into this operand stack. So this is evaluated, and now division operator is pushed. Okay, and then we'll again have 8 here again, and then we'll again have the minus sign, and here we'll again do this comparison. Every time we'll do this comparison, right? Whenever we are inserting into the operator stack, we will check if the stack dot peak uh, is having a higher priority, and so in this case the stack dot peak is having the higher priority. So division is having higher priority than the subtraction, right? So we will pop this division, we will perform 24 by 8. So whatever operator is popped from this operator stack, we will have that operator perform the operations on the operands. So 24 by 8 will give us 8 3s are 20, 8 3s are 24, right? Yeah. And this 3 will be then inserted into this operand stack that we have. Then this minus sign is also inserted into this, right? And then again 3 is inserted into the operand stack. So if you see now, the this expression is evaluated now. Now what we can do is that we don't have this operator stack empty. So we will iterate over this operator stack and we will try to solve this. So we get this operator and then we'll do 3 minus 3, which is 0. So 0 is pushed then. Then this is popped and then we'll do 3 minus 3, right? Yeah. And then we'll do addition of 2 plus 0. So 2 plus 0 will give us 2. And then if this is popped, and then we'll do that operation 2 plus 0, which gives the result 2, which is persisted into the operand stack, right? So let's check the answer. Yep, the answer is 2. So let us like whenever we are iterating it for doing this problem for the first time, it will be hard to catch. So let us write the conditions that we have. Okay. So uh, the first thing is that we have if ch, like ch meaning we are iterating over this string, right? So I'll call each character as ch. If ch is digit, then push in operand stack, right? And if it is not, then what we'll have to do? If ch is not a digit, then then we have to check the priority. Like there are two, three conditions that we will encounter here. But let's talk about those conditions uh, when we get those conditions, right? So if ch is not a digit, then check the precedence or check the priority with check the priority of ch with operator stack dot peak, right? If priority of ch is smaller than perform operation, meaning what do we mean by this? If we are having an element in the stack that has higher priority, higher or equal priority, higher or equal priority, right, than the element that we have here, then we'll have to perform that operation, right? And why do we do that? Because um, whatever operation that we have, let's say we have the operations 6 times 4, then we'll try to have this added. So division has equal priority to multiplication. So whatever is to the left has to be evaluated first. So we evaluate this first by calling this perform operation. Operation. Okay. Yeah. So once this is done, we can. So this is the base that we have. Okay. So let's try to solve some different variations of this. Like let's try to have this simple loop, right? Simple expression. So where did my question go? Yeah, it's here. So we'll perform the same operations that we have. If ch is a digit, then push to operand. So we push 6. This is the stack that we have. If ch is not a digit, we push to operator stack. Okay. Yeah, so one thing is that uh, before we do this, we'll have to check your digit if ch is not a digit. And so if we do operator stack dot peak directly when we are inserting here, then we will get an empty stack exception, right? If we are checking this. Mhm. So before checking the priority, first we'll have to check if stack is empty or not. And operator stack dot is empty, then push ch. That is what we are doing here, right? So if ch is not a digit, this is not a digit multiplication, and operator operator stack, not operand stack, operator stack dot is empty, then we push ch. We don't do any comparison. If we do any comparison, then we'll get an empty stack exception, right? Yeah. So we push this operator now. Then we push this operand that we have in this. So push 4. So once we are done we are done all of this, once we are done iterating, what we need to do, we need to iterate over the iterate over the operator stack. We'll have to iterate over the operator stack till it is empty. Empty and perform operations, right? So now we'll iterate over the operator stack till it is empty. So we will pop this. Okay, we are popping this. we get this and this element and we perform 6 times 4, which is 24. So we'll get the answer as 24. And we push this 24 into the stack. Okay. So this is how we'll approach these simple problems that we have. Okay. And whenever we perform the operations, then uh, after performing operations, get the result and push it into the operand stack. We have to do this every time, right? Okay. So we'll have some special cases also here. So let's say we have one scenario where we have, kind of this expression. Let's say we'll have some brackets involved in that expression. Let's say 2 times, let's say 5 plus 2 divided by 7. So now what care do we need to take is we'll need to handle these opening and closing brackets separately. So they generally have higher precedence, right? So if we did not have opening or closing brackets, then all these conditions that we had written here, they would be sufficient to write the code. But if we have opening and closing brackets, then we'll have to handle them separately. So how do we handle opening and closing brackets? So we can handle them. So closing brackets, what we can do is if we encounter if ch is a opening bracket, then we push to operator stack. And once we push it to operator stack, uh, we go ahead with the iteration. Then we encounter a closing bracket. Then what needs to be done is we need to perform all the operations present between the opening and the closing bracket. So if we encounter, like the fifth condition is something like if ch is closing bracket, okay, then what do? We perform operation meaning what we do, we pop the operator stack and then we get two elements from the operand stack and then we perform operations on those. Yeah, if ch is a closing bracket, then perform operation till we get an opening bracket and then pop the opening bracket as well, right? So yeah, these were the conditions that we have. So let's discuss how we will how this will work now. Okay, so in the operand stack we'll first have two. In the operator stack we'll have multiplication. Then in the operator stack we'll have opening bracket. Then in the operand stack we'll have 5, right? Then in the operand in that stack, the one that uh, we have pushed 5. Then in the operator stack we'll have plus. Okay, in the operand stack we'll have 2. So if you observe this, like whenever we encounter an opening bracket, we don't check the priority and all, we just push the opening bracket. Okay, then we encounter a closing bracket now. So whenever we encounter a closing bracket, what do we need to do? We need to perform operations by popping. So what we will do is we will pop from operator stack. So we pop this and then we perform addition of these two because we have plopped plus. So we'll do 5 plus 2, which gives us 7. And whatever we pop, we insert that into the operand stack again. So this is what is popped. And then we encounter a closing bracket. Then we stop performing the operations that we have here. Then we just pop the opening bracket that we have. Yeah. So this is how we have we will tackle this opening and closing brackets. Then we move on further. So we don't insert this closing bracket, right? We move on to the next character. So whenever we have an division, we will check the priority, right? And we check that the priority is same of division and multiplication is same. So we will perform this operation first, which is 7 times, uh, which is 2 times 7. So we'll pop this and we'll do 2 times 7, which is 14. And what we do is we persist this 14 into the stack. Okay, and then we'll have the operator in this pushed in this operator stack. Then what do? We insert the next element that we have, which is 7, into the operand stack. Okay. Lastly, we iterate over the operator stack till it is empty, right? So we iterate over this operator stack, we pop this, and then we perform 14 by 7. 14 by 7, which will give us 2. And this is how we'll get the final output, right? Yeah, so the element present at the operand stack, if we do a operand stack dot pop or operand stack dot peek, we will get the result that we want of the infix expression. Yeah, so let's try to solve this. Okay, let me create a class, excuse me, called infix expression. So here what we will do is we will only take enter a string, enter string or an infix expression, let's say. Okay, once we enter it, it is a string, right? We remove all this logic. Okay, so we'll iterate over the string first. Iterate over ftr dot length. Then we have identified 2, 3 conditions, right? So the first condition is we check if character is digit or not. So we check if, how do we check if a character is digit or not? So we have a handy method in the character class. So character dot is if digit will check if the character is digit or not, and it will give us. So let's have this character ch is equals to ftr dot caret I. Yeah, if it is a digit, then we'll have to first create stacks, right? Stack. We have an integer stack which has operands. Then we also have a character stack which is of operators. Okay, so we iterate over the expression, we check if the character is digit or not. If the character is digit, what do? We put that into the operand stack. Okay, let me have this stack also written here. Print stack dot push. We push that character. Else, so the second special case that we saw was if ch is and opening bracket. So if it is an opening bracket, we directly push. We don't check for any other things, right? So we push into the operator stack dot push ch. So operand stack dot push. Okay, so what we'll have to do, so this ch which is present, it is in a character form. So we'll have to convert that into int form. So what we do is that we subtract by 0. Once we subtract by 0, we will get int format of this character. Okay. So once we encounter a closing bracket, we directly push it. And the second and the third edge case that we have is if we encounter a closing bracket, then what do? We perform operations. So we'll have some logic here to perform operations. And till when do we perform operations? We perform operations till the operator stack dot peak is not equals to closing bracket. No, not an opening bracket, right? So from closing bracket to opening bracket. Yeah. And we'll have pop here to pop the opening bracket that we have. And then in the else if condition, we check. So here we'll have the logic for perform operation. Okay. And if ch is equals to plus, or we can have these conditions here, right? Ch is equals to minus, or ch is equals to multiplication, or ch is equals to division. Like these are the operations that we have. Yeah. So if we have this, then we have to check priority and then perform operations accordingly. Okay. So we'll have some uh, reusable code for this perform operations logic. So let's have it in another method. So this perform operation, it will return an integer which will have to persist into the operand stack. So this will be also be a static. Let's have it as static. So what it does is it returns an integer, and what functionality is performs is operation. It takes some values. Okay. Let's say if we have int v1, int v2, and it has a character. Characters, let's see, operator, char operator. And if the operator is addition, then we perform v1 plus v2. Basically, we return. Else if it is subtraction, then we return v1 minus v2, right? And we'll have one more else if to check if it is multiplication or not. We'll perform v1 times v2. And lastly, we'll have v1 by v2 for the division operation. And we'll also have to write some logic to check the priority. Okay, so let me copy this, and we'll have priority. So this priority method, it will give us the priority. So it will take and operator, okay, and it will give us the priority. So if priority is, if the operator is plus, priority is 1, let's say. So plus and minus have same priority, so we return only 1 for those. And for multiplication and division, let us return 2 because they have higher priority than addition and subtraction. Yeah, so let's write the logic to perform operations here. So how do we perform operation? So we perform, first for performing the operation we need the operands. So we'll need two operands, like uh, we'll need an operator first and we'll need two operands that we have. So 5 and 2 are the two operands, let's say. So we'll have to get those. So what we do, we pop from the operator stack. So this will give us the operation that we have to perform. So let's say we have this as operator. We have ch, right? Char as the operator, yeah. Okay. And once we get the operator, we'll have to get the operands now. So we get those by popping the operand stack. So let's say we get int v1. So we'll have to perform operations in this manner, right? So let's say we have 5, 5 minus 2. So how will we perform the operations? So we'll perform operations. So first we will have to push the operands and the operators. So we push 5 first, then we push the subtraction sign, then we push 2, right? And while performing the operations, we pop this first. So that is what we have done here. We have popped from the operator stack. We pop it, then we get both these elements. So how do we get both these elements? We pop 2 times. So for the first time, let's say we get v2. So why are we having v2 here? Let's discuss that. And for the second time, we get v1. So while subtracting, we'll have to have something like 5 minus 2. Okay, but whenever we are popping for the first time, we get 2, right? So we'll store that in a variable called v2. We are doing that. Then we will have another pop and we will get 5. And then we'll store that in v1 variable, let's say. And then we'll have to perform operations using v1 minus v2. And what operation do we have to perform? The operation that we get from this operator. Okay. So we'll call the perform operations will supply v1, v2 and the operator. Then we get the result of this operation. So let's say we have this result. Okay. If we get this result, once we get this result, we process that result in the operand stack dot push result. And once we are done, we just pop the uh, opening bracket that we have here. So this is the logic for performing the operations. Okay. So in this code, now what we'll have to do is we'll have to check the priority. So how do we check the priority? So a simple way is uh, we can call this priority method. So if priority of character that we have is less than or equal to, so you can refer these nodes that we have. So if you see, we have to check if it is not a digit, then check priority of ch with operator stack.peak. If priority of ch is smaller than or equal to the or uh, equal to this, right? Smaller than or equal to the operator stack.peak, then we perform operations. Okay, we perform the operations, we get the result and we persist into the operand stack. So if priority of ch is less than or equal to the priority of operator stack dot peak, then we perform operation. So this is the operation that we perform, right? I'll remove this. And there are other conditions also, right? So that we have. So one condition is if ch is not a digit, then check priority. Okay, so this is the third condition. So before this, we have one more condition. If ch is not a digit and operator stack is empty, then push. So we have to push after this, right? Operator stack dot push. What do we push? Ch. So we'll have the additional check as we discussed here, right? If the operator stack is empty, then we push. So we won't go into this operator stack dot peak, otherwise we'll get an empty stack exception. So we'll have an operator stack dot is empty. Check here. So it should not be empty. As well as there is another special case that we have. So we don't have to iterate if we see an opening bracket. So we have to stop once we encounter an opening bracket, right? So we don't have to perform operations if we see an opening bracket, because then suppose let's say we have an expression something like 2 plus let's say 5 times 1 divided by 5. Okay, so what will happen here is first 2 will get uh, into the okay, so what we can do is we'll have 5 times 1 plus 2. Okay, plus 5. Okay, let's do this. Yeah, so if we have this, then let's go over the iteration. So first we'll insert 2, then we'll insert plus here, then we'll insert an opening bracket into the operator stack, not here. Yeah, then we'll insert 5, then we'll insert multiplication. So once we are entering this, we have to make sure that the priority, we don't have to check the priority and all those things, right? So so you'll see that this operator is having higher precedence than the uh, the closing brackets, right? So this was the special case that we discussed. So if we encounter a closing bracket, then we don't have to check the precedence as well. So before checking the precedence, we'll have to check if the precedence or the priority, we'll have to check if the stack.peak is an opening bracket or not, right? And once we have this stack.peak, uh, which is not a opening bracket, we'll continue the iteration. So we'll insert 1, okay, then we insert plus. But before inserting plus now, we will check if stack.peak has higher priority. And yes, it does have higher priority. So what we do is we do 5 times 1, which is 5. And we persist this 5 into the operand stack. So we have this 5 into the operand stack. Okay. And then we don't have to evaluate further, right? So we will have to evaluate only till here, right? From this to this. So for that we will have an additional check. So before checking the priority itself, we'll have that check, right? We'll have a check which says that we'll have to check if ch we'll have, what do we need to check? If operator stack if operator stack dot peak is not equals to a closing bracket, right? Not an closing bracket, an opening bracket. So for those conditions, we don't have to perform these operations, and we'll have to perform this priority check again and again, right? So we'll have this in a while loop. Okay. So we check if it is not empty. If it is not empty, we check if the peak element at the operator stack, it is not an opening bracket, and then we check the priority. Yeah, so once we are done with all of this, as we discussed, we have to have one more loop, right? So this last condition. We iterate over the operator stack till it is empty and we perform operations. So we'll have a while loop which iterates over this operator stack. So we'll iterate till it is empty. We'll have a check here that it is not empty. And we perform operations here in the same way we have done here. Yeah. And finally, after we do all this, we have whatever element that we have in the operand stack, we have that as our result. So yeah, that was not a difficult problem, but a lengthy one. But let's try to run it once and verify. So if we have 5 minus 2 and we get an error, we get it at this condition. Oh, we have to check if operator stack dot is empty, not operand stack. My bad. We have 5 minus 2, which gives us 3, right? So we check if the operator stack is empty or not, right? So we had discussed that for the 5 minus 2 question that we had solved. So what we will do is that first the operator stack is empty. So we'll push 5 first into the operand stack, then we push minus. So before making the pushing the minus, we are checking the peak here, but that's not what we want. We'll have this additional condition. So even if the stack is empty, we just push, right? If the stack is empty, it will not go into this perform operations loop. It will just push here. Okay. So we have tested one base case. Let's test the other base case. Okay, let's say we'll have 2 times 5, let's say plus 2 divided by 7. Yeah, so we get the correct answer. This is 7 divided by 7. Yeah, so how will this be evaluated? This will be evaluated first, which gives us 7. Then this will be evaluated. 7 times 2 is 14, and then this will be evaluated. 14 by 2 is 14 by 7 is 2. So that is the output that we have. So yeah, that's all about this question. See you guys in the next one. Thank you.